Hello, and what I'd like to do today is start Unit 2. This is going to be biochemistry, where we're going to talk about the chemistry of life. And in the first section, 2.A, we're going to talk about 6 common elements that make all living things and pH. Just a few slides, should go pretty quickly, I hope. So what are the 6 common elements? Well, it's got to start off with carbon. Carbon is the one atom that actually makes things considered organic. If we mix them with hydrogen and oxygen, that is an organic molecule. So it does have to have carbon. Neat thing about carbon is it can actually bond with 4 other atoms. It's almost like it's an atom with 4 arms that will grab onto anything it can. What it likes to grab onto the most is hydrogen. Hydrogen also likes to grab onto things, so it makes it very likely to happen. This is a methane molecule, but other hydrocarbons like plastics, motor oil, diesel, gasoline, all made with carbon with 1, 2, 3, and another carbon for the fourth, or that carbon with 2 hydrogens, 2 carbons, will grab onto 4 other things, making these long chains of hydrocarbons, which we utilize for making plastics, for greasing moving particles, for diesel fuel, and also gasoline fuel, as well as the 4 organic compounds that make up all living things. The other things, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Trick to remember all these guys is to take the first letter of this order and you get a word that's called CHNOPS for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And I'm going to give you this slide at the very end of this project, or really close to this particular unit, where if we take those, we get hydrocarbons. If we actually add oxygen to it, we get living molecules, carbohydrates and fats. And then if we put nitrogen in, we can get amino acids and proteins, and sulfur makes more amino acids and more proteins. And if you put phosphorus in there, you actually get nucleic acids, RNA, and DNA. So if you get all of them together, you can make these. If you get these 5, or these 4, or these 3, or these 2, you get different materials. So we got to talk about reactions. We got to talk about how these things come together. And what we do is we actually talk about reactants, and then we have this arrow, which actually means what does it yield, and the reactants yield products. Things like red and blue as the reactants yield the color purple somewhere. And if we take this example, which is peanut butter and jelly, one of my favorites, especially if it's Jif, makes a peanut butter sandwich. pH, which stands for the power of hydrogen. The more hydrogen ions you have, the more acidic you are. The less you have, the more basic you are. If you don't have hydrogen, you have hydroxyl, and we'll talk about all those things in here. But the power of hydrogen can actually be sampled probably in your house with different items, between juices and cleaners. We actually do have most of the pH from one. We use one, like if you use oven cleaner, that's a very basic thing, or if you can use like lemon juice, that's a very acidic thing, and if you use water, it's right smack in the middle. So let's talk about acids, neutrals, and bases. Acids are anything that's less than 7, so 6 is a little acidic, and 5 actually is more acidic, and 0 is the most acidic. And this is a power of 10, so that a 6 is 10 times more acidic than a 7. A 5 is 10 times more acidic than a 6, or 10 times 10, 100 times more acidic than a 7. And it keeps going until you get to 0, which is 1,000,000 times more acidic than a 7. Things in acids, like what they basically do is they produce hydrogen ions. Hydrogen ions are the things that actually make these things acidic. And the more hydrogen ions you have, the more sour you taste. And I'm going to tell you bases taste bitter, and I'm not exactly sure what the difference between sour and bitter is. Your tongue can tell the difference, and I can tell the difference, but I can't really explain it. Neutral is 7. The best example of neutral is water, and this is not water you find in a river, which actually has been dissolving material and maybe a little basic or a little acidic. I'm talking about water that you can create in a lab through a process like distilling the water. And if you get pure water without the other additives in it, you can get a 7. Bases are anything that's more than a 7, so an 8 is a little basic, a 16 is the most basic, where this is 7, this is also 7, so this is a million times more basic than a 7. Bases are caused by what are called hydroxyl ions, and notice this is a negative ion where this is a plus ion, and if you put those two together, that hydrogen will bond to that hydroxyl, making a neutral ion of two H's and an O will make water. This does taste bitter, and I do want you to know that seawater, if you ever take an oceanography class or when we study the rest of biology, we'll actually notice that the 7.5 to 8.4, this 7.5 is the same as your blood. So your blood has the same pH as seawater, and some people are actually saying that maybe when we climbed out of the ocean, we took the part of the ocean with us, and it's kind of amazing that the human blood, the liquid inside your body, is the same as the ocean that maybe your ancestors crawled out. If you take an acid like hydrochloric acid and you take a base like sodium hydroxide and you put them together, you yield them, and what you'll actually yield is a water molecule. That hydrogen and that hydroxyl come together to make a water molecule, which is stable and a pH of 7, and will actually make a salt. In this case, the sodium and chloride ions come together. The plus and the minus will come together to make a sodium chloride ion, which again is neutral. And so we can take an acid and a base and make two neutral molecules out of them. If you look at pH, you actually see this range. Neutral in the middle is 7, and you get lower numbers are acidic. The more hydrogen you go this way, hydrogen ions, the more hydroxyl or less hydrogen. So this is the more hydrogen, less hydroxyl. This is the more hydroxyl, less hydrogen. And again, it's a power of 10. So this is 10 times more than this one, 10 times more than this one. So 100 times, 1,000, 10,000, 100,000, a million, 10 million times more acidic than a 7, just like this is 10 million times more basic than a 7. And there's no difference. If you put this on your skin, it'll burn. You put this on the skin, it'll burn. Here's another depiction where you've got the numbers from 0 to 14, 7 being pure water, with 0 meaning that it doesn't have any hydrogen, and you go 10 times, 100 times more hydrogen, 1,000 times more hydrogen, or you go 1/10 the hydrogen, which gives you the hydroxyl 10 times, or 1/100th, or 100 times hydroxyl. But since it's the power of hydrogen, it's talking about increasing numbers of hydrogen and decreasing amount. I would like you to write down the ones that I've got a green line here. I'd like you to write down battery acid, hydrochloric acid, which is the stuff that's actually in your stomach lining, and why you can get an ulcer and a perforated ulcer because your stomach is very acidic. Vinegar, which you can find in your households, around a 3. Soft drinks are a 3. Black coffee a 5. Urine, really close to pH of water. It's got a little bit of material in it which makes it a little bit more acidic. Milk and magnesia, which you take if you do have an acid-ish stomach, because you put in a base and you put it into this, it actually neutralizes it up a little bit, makes it more likely to not hurt. Household ammonia, which is a cleaner, is around a 12. Oven cleaner, 13. And drain cleaner, if you've ever seen drain cleaner, you normally do that with rubber gloves because you don't want this to be on your skin, just like you don't want battery acid to get on your skin. So the more hydrogen, the less hydrogen, more hydroxyl ions for pH. And I think that's it. Okay, thanks for stopping by. And next will come 2B, which will be the water molecule.